Okay, happy Thursday. Let's get started. So far so good with my machine. I just hope it holds up. If any of you, several of you looks like our Mac users, I mysteriously had an ailing computer after I updated to Mac OS 10.15.3 yesterday, and so my fingers are crossed the whole thing won't just explode in a ball of flame. And if it does, I've got dry erase markers as backup. Can everybody hear me okay in the back? I'm using this mic, appears to be working again, so I'm using that. If you can't hear, go ahead and raise your hands. So I've got one announcement. Yeah, you can't hear me? Okay, so maybe if I get this closer and, all right, everybody's arriving. How about that? Is that a little bit better? Okay. So my apologies. There were two students who were able to make it into office hours who possibly broke through a window or something. I don't know. We've had an issue with the door being locked on 2232 Piedmont with staff being sick and things like that. If you are up there looking for office hours and you can't get in the front door, please email me, or you could usually knock on the door, and some of the grad students who are hanging around usually will let you in. So my apologies if anybody arrived. I noticed this after going out to lunch, then coming back, it was locked. So sorry about that. Any other announcements? Any of the GSIs have anything to? Great. Okay. All right. Well, we are moving steadily ahead through some of the key parts of the course. And it's kind of a nice thing to say that we're making good progress through these bits that will be on the exam. So I can almost guarantee you that the Malthus model and the solo growth model will be on the midterm exam. Whether they're on the final or not is a little bit less clear at this point, and so we'll talk about that during the review session. The way the final exam will work is it'll be cumulative, but it might not touch on everything that we've done over the entire term. Today, I wanted to talk about some of the tough parts of economics in your undergraduate studies here, because they arose in speaking with students who had questions after class on Tuesday, and they also arose in office hours. Very, very good questions, and they all kind of cut to the heart of these tough aspects of economic analysis that we see here and also in the intermediate courses. The concepts of short run versus long run, it's kind of a fuzzy one. And I thought about trying to make it more formal, and I thought, I don't know if that's going to work. So I'm going to try to keep it fuzzy, but explain it a little bit better, I hope. And to be honest, at the end of the day, I think where one improves one's grasp of this is through repetition and practice. It's through study groups, it's through using Piazza, it's through coming to office hours and optional section and talking to folks during class and after class, et cetera, asking questions. I think that's the right way forward, but I did think it would be useful for me to spend some time talking about this in a somewhat more structured way. Short run versus long run is a big issue in these two models, and it's a big issue in any model that really attempts to describe reality, because there's kind of the immediate stuff that happens, and then what happens to humans down the road a bit. And so any good model should do that. Then also the perennial question is an exam question, rather, I suppose, asking you about something that is a movement along a curve, or is it a shift in a curve, or shift of a curve? And that's always the $10,000 question. So we'll have some examples from Malthus that'll help a little bit. Hopefully you brought your iClickers today, and we'll run some iClicker questions. And then we'll plunge back into the solo growth models we started on Tuesday. So we'll talk about production functions, the steady state, population growth, and technological change. Questions about this, about the roadmap? Okay. So, the wording was there in that second iClicker question on Tuesday that I put up there, but it wasn't, I don't think, in bold. I asked about the long run, and that was, I think, something that tripped up a lot of folks, and I don't blame you for getting easily tripped up with that. So we'll try to make clear what we're asking about in the question, and what we're asking you to think about modeling. And if it isn't clear, please just ask. So obviously that's a little easier when we're actually in an exam, and you can just flag down one of us as we're proctoring the exam. You can ask. It maybe it's a little bit less easy when I'm up here, speaking 3 million words a minute or something like that, and you need to stop and clarify. But just give it a shot. Raise your hand and ask. So short run versus long run. Time is important. We don't just have a sort of a static view of things. Things evolve. People are born, they grow older, they have children of their own, they age, they retire. This is all a story about time, and so it's important in demography and in economics. Some things can change very quickly, other things usually don't change quickly. And so the key word here is usually, because I realized as I was writing up these slides that there actually are plenty of examples in which we imagine a scenario in which stuff that usually doesn't change quickly actually does, which it can. It just all sort of depends a bit. But there are things that usually don't change very quickly and things that do. A realistic model or a forecast draws this distinction, and so that's part of the reason why it's there. You want to have something that's useful. When Congress passed and the president signed the tax cut of 20, whatever that was, 18 or 17 or something, the Congressional Budget Office had a model of what the short term, the immediate consequences were, or likely to be, of the tax cut, but also the long run consequences of the tax cut. And of course now, several years out, it must have been 2017, I guess, we actually can check, right? We can see whether the CBO, the Congressional Budget Office, actually got it right or got it wrong or what. And they do a very good job usually of trying to sort of update that and tell you what the deal was. So here's a table of two types of things that show up in these models. These are all, I guess, variables, if you like, but some of them we think about as being maybe more like parameters. Some are variables, or you can just think of them as concepts. So on the left, things that can change quickly include things like people's preferences, right? I change my mind about stuff all the time. And so we might imagine a story in which we're trying to trace out the effects of a very quick change in somebody's, preferences about going to work or playing video games or something like that. I have that conundrum all the time. Or it could be a preference about the number of children that you might like. And if you're like me, that is something that might fluctuate a ton over your lifespan. And then when it comes down to actually making the choice, you have to take a long, hard look and figure out what it is. But your choice can change very quickly. It can depend on your circumstances, on your partner, on the price of doing everything, on how many fertility treatments one might need, for example, and how expensive that is, what your health insurance looks like. So preferences are what they are. They can change quickly. I guess that's also a story about a budget constraint, if you're thinking about your health insurance and what it can cover. Birth rates can change quickly. The birth rate can change quickly. The total number of births, of course, is the product of the birth rate and the population. Population is the thing that's on the right-hand side, which typically cannot change quickly. Yeah. So let me just pause, though, and say, so population usually can't change quickly, except, right? So that's the usually part. What can change population very quickly? A plague could change it very, very quickly. And so then in the context of the Malthus model, you might immediately then ask, if this is on the exam, a plague hits, what happens? And your question ought to be, dear GSI or Professor Edwards, so is this like a very quick sort of plague, or is this something that kind of produces a rise in mortality rates that lingers a long, long time? And you could think of it as being either one. I think we're more accustomed to modeling it as the former, that if there's a plague that kills a lot of people, they're all dead, right? Not quite totally realistic, but if you look at the the chart of English population back around the time of the Black Death, in fact, that actually did happen in a rather scary way. Another good example is on the tip of my tongue, and I wonder if anybody else has another thought about what can change population quickly. War. Yeah, right. That's the big one, right? War can change population very quickly. And I guess you could actually think about it in two ways. One is the mobilization of labor that takes everybody overseas, and that was the bigger part of the story for World War II for this country, was the mobilization of mostly men and also women into the armed forces and overseas. But then, of course, for many other countries that were harder hit by World War II, it was actually the combat and infectious disease fatalities. And it's really horrific in places like Russia and other hard-hit countries during World War II. So those are the kind of the big ones, I think, and there probably are others. So right, usually can't change quickly, except, well, they can sometimes, but in the model, it's a slow adjustment. Birth rates can change, but that's going to slowly increase the population if you've got a higher birth rate than you did before. So population growth rates then are also like birth and death rates. The population growth rate can change quickly, but the level of the population typically can't. Prices and wages can change very quickly. That's our indoctrination of you all as economics professors, that we're telling you that, and you need to at least pretend that it's true. All right, there's sort of an asterisk there as well, but let's not get into that. Let's wait for graduate school if you're interested in that sort of thing. It is true that wages and prices can tend to be sticky. They don't sort of change quickly, but the way to think about this is, I don't know, StubHub, right? What happens on StubHub to the price of Giants tickets if they lose their first 81 games? It just plummets very, very quickly, right? What would happen to the price of StubHub Giants tickets if, I'm trying to think if Buster Posey has another concussion, right? That would happen very quickly, and the price would adjust very quickly. So that's the thing to keep in mind is kind of the perfect internet world of prices in which things just change rapidly because if you didn't have frictions, they probably would. Saving rates also can change very quickly. Of course, the question is whether they do or not, but they could in principle. Technology adoption, there again, it's, well, how do you adopt technology? You have to learn about it, so that might require reading or going and visiting somebody who's actually done the technology, so it gets more complicated in the real world. But the point is that if you think about how this happens, it's not the same as having to build like a warship or a jet or a building. It's more quick than that. It's reading and communicating. And so the classic idea is, well, suppose you are I think this is actually true, right? You're a pilgrim, you're a Protestant from refugee, basically, from the United Kingdom, and I think also from maybe Holland as well. You show up in the New World, and you start starving because your agricultural practices are relevant for East Anglia in the UK or something, and they're not relevant for the Boston area, which is notoriously tough to grow stuff in. And so you learn how to plant your corn with a fish. You toss a fish into the ground, and that fertilizes the corn. That's something that can happen very quickly. You have to find a friendly native of the land where you're moving in, and hopefully you all get along and you're not yet committing genocide and all these awful things that come along with it, right? So if you talk to that person and they say, you know what, put a fish in the ground, that'll help your corn and you won't starve. That's quick. And so that's an example, a classic one, of what you can see in the Malthusian model or the Solow growth model, quickly, some kind of technological diffusion that makes everybody more productive very quickly. So along with population, on the right-hand side, the other things that can't change very quickly are capital, land, natural resources, and the environment, we think, generally. I think we're running the experiment to see exactly how quickly we can destroy the atmosphere with global warming. I don't know, but we'll see. I think the belief is still those are fairly slow types of things, except when they aren't. So we'll try to be very clear about that, and if it's not clear, ask a question. So here are some examples of preferences. It might be things about family size or your preferences about saving. What's saving for? Is it for you? Is it for your children or grandchildren? That kind of story. Birth rates might be something about contraception or possibly structure of families and female empowerment. Those kinds of things, I think, would fit into examples of why birth rates might change quickly. Death rates, a story about, say, permanent diseases or treatments for particular diseases, maybe Alzheimer's or cancer would kind of be the story, I think, these days, beating those back and possibly lengthening life. Population growth rates then react to those things. Also, prices and wages can react to productivity shocks, for example. That's a real common one. Saving rates, we talked about, and I guess, and this shows up actually in an iClicker question too, that a depreciation rate is kind of a tough thing to think about, but maybe climatic change actually affects that. So if you've got a climate in which capital goods deteriorate much more quickly, you might imagine this being a bigger problem, a higher rate of depreciation for for fixed capital stuff. I bet that's probably true, across the 50 states, especially if one thinks about places like Alaska or Hawaii, which are kind of extreme in terms of their climate. As you may recall, the census is actually already happening in Alaska because it's so darn cold. It takes so darn long to get all over the state. And I would imagine that probably has real implications for the depreciation rate of the fixed capital that's there. I don't honestly know. I've never lived there, but so that's kind of a legitimate thing. Okay, things that usually can't change, and so here I'm listing exceptions, and so a mass immigration might very quickly change the level of population. We haven't seen too many examples in sort of documented history there. I guess in the Bible there are some mass immigrations and all that that were probably large. I don't know. In modern times, one of the big ones was Castro decided to let a lot of Cubans leave in what later became known as the Mariel Boat Lift. And that produced a bunch of Cuban immigrants in America that swelled the size of the Cuban populations in Miami primarily, and also spilled over elsewhere. Yes? Oh, I think that is a fantastic example. The partition of India, I think, yeah. And so I don't know much about that, but it sounds like a very big change in population very quickly, yeah. And so I guess what you would imagine is it's in India and Pakistan, yeah, became two countries. Yeah, that's a great example. So with capital is something that also tends to stick around and not change much unless you have a war that destroys it. And so that's kind of the canonical Econ 100B, I think, right? Intermediate macro example of what to do in the solo models to think about, suppose you got a bunch of capital, but then wars destroy it, like World War II. What happens to growth rates? And the answer is they skyrocket because capital gets reaccumulated. And that's a big part of the story with post-war growth in a lot of, at least Western Europe. Behind the Iron Curtain, I think the story is somewhat less clear, but similar, probably. Okay, so question marks would be this stuff. I think that's fairly straightforward. Based on the remarks, I think people get this. Are there questions before I say a few more things? So the upshots. So usually stocks like labor or population or capital usually don't change very quickly. In the short run, then they don't change. They are set at whatever you were stuck with before. So if the exam question is, okay, so suppose the birth rate rises in the Malthusian model. What happens in the short run? And the answer is, well, the birth rate rises, but the population is the same. And so you would, over time, see a shifting up of the birth curve and then a growth in population. And of course, that's going to decrease wages because you've got this fixed labor demand curve. So with more population because of the increased births, so it's that kind of story. But in the short run, you've got the same number of people. They're just having more babies for whatever reason you might have. Population is a stock and it doesn't change quickly. Okay, but in the short run, vital rates like, say, the birth rate and the death rate can and do change, and so can prices and wages. So things can change in the short run. In the long run, what does the long run really mean? Well, it means later, a bunch of time later. It means when things have kind of settled down into an equilibrium or a steady state. And in all my years of studying and practicing economics, I've never really come up with a good parsimonious way of explaining this. So maybe we can refine this over the course of the term or the next several weeks when we're really talking about this a ton. It's sort of an art in a way. Well, what do you mean by an equilibrium or a steady state? Well, when things are well behaved. But in some models, there might be steady exponential growth in things even in the long run. So that's going to be true in the solo model, that there actually is stable long-run growth in the steady state. Some things are constant, namely growth rates, but other things are actually growing, but in a stable way. So, I don't know. I find that tremendously confusing, and I wish I could find a way of making it less so. But that's my story, and I'm sticking to it, and we'll see how we maybe can refine that a bit. So the specific story then about the Malthusian model and the solo model are the following. In the long run, you'll see that where the birth rate equals the death rate, which is the crossing in that upper diagram. And it has to be at that point because if that weren't the case, then births are not equal to deaths, and that means the population must be moving in one way or the other. And if that's true, then you've got to be sliding up or down on the marginal product of labor curve, the labor demand curve, and so the wage is not the same. So nothing is stable then if this initial condition isn't met. In the short run, maybe the level of the birth rate and the level of the death rate are not the same. But in the long run, they have to be, because that's the only way that you actually end up getting something. Okay. In the Solow model, the long run is where saving per person equals total depreciation per person. And that, it turns out, is also the crossing in the diagram. So the good news is, just like in microeconomics, when you get, demand and supply, and the story ends at the equilibrium, which is the crossing there. Here, there still is a crossing. The problem is that it's a little more complicated than that. That there's a crossing, but it doesn't necessarily mean that things are not changing. In the Solow model, they actually are. There's growth in population, and also growth in capital and growth in output at the steady state. Okay, so I admit, I think maybe what we ought to do is just go ahead and march ahead into the examples of this. I think that's probably a little bit more helpful to you. But do please flag me down and ask a question if stuff isn't clear. Okay. Moving along a curve versus a shift in a curve. There are a couple of things to say about this. One, and this is a little bit more sort of hand-wavy, think about the scenario and about the y and the x variables, where the y variable is a function of the x variable. So x is the independent variable, y is the dependent variable. It is a function of whatever x is doing. If the scenario suggests that the x's are changing, then this is probably a movement along the curve, because y is equal to f of x is this statement about a function, and that is the curve that you're looking at. So if the x changes, it's just a movement along the curve. If instead the scenario implies that y is changing independently on its own for some other reason, why would it do that? Well, there are other parameters in the function in addition to the variable x. If that's the case, then it's probably a shift in the curve. So that's the kind of fuzzy way of talking about it. I personally like looking at the math. Now, some folks like this, I do. Some folks don't. And if we were to get mathy on all the exams, and note the subjunctive tense there, if we were, we would let you know. As it is, the course has some math, and it's there if you like it, and doesn't have to be there if you don't like it. And I don't think in the history we've ever asked anybody to take a derivative of anything on an exam. So we're not going to do calculus per se, but there are ways of mathing this up to make it more useful, and talking about tangent lines and things like that. And of course, you've seen that if you're an econ major and you've taken 100A and 100B. So there are ways of doing that, and if this is useful to you, then by all means dive in and think about it this way. So underneath both of these models, and honestly also underneath the model of Sauvy, except there's kind of an asterisk there because there's more to it than that, is this constant returns to scale neoclassical production function. So the left-hand side, the y variable is output. It's a function of inputs. And the inputs are the physical factors of production, whether it's land. Here I'm calling it lambda, and I'm putting a bar over it just for kicks. So lambda is land, and it's fixed. It's got a bar over it. That's what we do. We use Greek, and we put bars over things when things are fixed. N is population, and you'll notice here, so sometimes the slides use the little letter a for an exponent. That's fine too, and then 1 minus a. You'll notice that 1/3 and 2/3 sum to the number 1, and that's pretty important. That gives you constant returns to scale. And then, and here's, if you like the calculus part, the first derivative of this with respect to n gives you the marginal product of labor. I've left it as L here, but it's actually the variable n, and it's equal to this math. And so if you happen to graph it using a graphing calculator or something, and the only important part here is the thing that changes, which is n to the minus 2/3, you see something that looks like this, and lo and behold, that's the labor demand curve. So if this is helpful to you, then that's awesome. If it's not, then until further notice, don't worry about it. But for me, this is gold because I can look at it and I can say, well, what's a movement along the marginal product of labor, the demand curve? And the answer is it's a change in the population. That's the variable here, n. What's a shift in the curve? Well, it's a change in the number 2/3. Well, not really. 2/3 doesn't actually change, does it? It's just 2/3. It's this, it's the productivity parameter, the thing that multiplies everything. So if productivity increases, that increases the value of this thing for all levels of n, and that's an outward shift in the curve. If the amount of land, lambda, were to miraculously increase or decrease, I guess that's not miraculous, but if it were to tragically decrease or miraculously increase, that is also a shift in the labor demand curve. So for me, I love algebra and calculus and all that stuff, and that's probably true about the GSIs as well, because we're doing demography stuff. You do a lot of mathematical things, and this is gold. I love it. So if that helps you, then that's great. Questions about that? Yes.
Why is n to the negative 2/3 power?
Oh yeah, why is n to the negative 2/3 power? Because I made a mistake. It should be negative 1/3, right? Thank you. I can't remember when in the last harried 12 hours I was doing this. Let me just go ahead and fix that right now. Yeah. So as you all remember from calc, right? Calc 1, it's you take the exponent minus 1, and that should give you 2/3 minus 1 is 1/3. All right. And hopefully I'll remember to fix that in the PDF. The nice thing is that a mistake like that would get you wrong if you were calibrating with actual data, but it won't screw you up if all you want is the qualitative point here, because a negative exponent is a negative exponent, luckily. So in terms of errors, it's a fairly banal one. And I guarantee that if I were grading the exam, I would not dock you on that because I probably wouldn't even notice. The point is, which way did the thing slope? And so as long as you've got a negative exponent, you're good. Yeah. Other questions? Okay, well, if that's helpful, great. If it's not, that's okay. Yeah, I like to get all mathy myself. Okay, so let's talk about, in the Malthusian model, the effect of exogenous technological improvement. And so, let me, I guess, flip back then. So again, I like, just looking at the math. Well, if technology is this parameter here that just multiplies everything, it's scaling the marginal product of labor curve up or down, and that is, it's shifting it. It's not a movement in the amount of labor n, or population, it's a shift in the curve. And so the story would be, if you had a new technological breakthrough that just fell out of the heavens, or you managed to talk to another human in another tribe or another population separate from your own who told you something really valuable about how to be more productive, it would look like this. You would see this across the board outward shift, or I guess rightward shift probably is a better way of saying it. So at every level of population, you'd find a higher wage, a higher level of productivity. And in this model, of course, workers are paid their marginal product. And so a rightward shift in all this, and then it would stay right there, because provided that you don't lose the knowledge, you never become less productive. Again, this is a permanent shift. And here we see the differences, though, between short run and long run. So in the short run, what happens? So does population shift in the short run? No. What can shift? Prices and wages. So we're in the short run, we're stuck at n star, and the wage jumps up to this, I guess we could call it W prime. It's not labeled as such, but it's a level of the wage that's above W star. You've got a certain amount of labor, they're more productive, and then what do? They just blow it all, right? At least their death rates are falling. I guess that's usually the reverse of what happens when they just blow their cash. It turns out that this is actually true, that if you look at data, it turns out that there are more accidents on paycheck day, more hospitalizations because of drinking too much. It's true. And it's because people have cash in their pockets. So having said that, that's the real world today. In this world, in fact, that doesn't happen at all. People are very good and they don't do anything with their cash except have more babies. They die less often. They're richer, so they can afford the horse rather to leave town when the pestilence hits and everybody's dying of the seasonal flu or whatever it is. So the death rates actually fall, but they go and well, they go back home, I guess, don't they? They get married more. I guess that's kind of the deal, right? You come into some more wealth and you get married finally, and your future father-in-law, says, fine, all right, I'm the patriarch in this old antiquated society, and fine, you can marry my daughter. All right, that's the Malthusian model for you, and that's why that thing rises so strongly with the wage. So the birth rate rises. There's not a shift in the curve, though. And that's a little harder to see if you wanted to in the kind of the math version of this, because I thought about introducing a formula for this, but I think that just complicated it. There's no shift in the birth curve. We're just moving along the green curve up to the right here at a higher level of births, and also moving along the red, or rather orange curve here down toward in the southeasterly direction toward Florida there. So we're starting here in St. Louis, we're going up to Boston, and then here we're starting in St. Louis and going down to Miami. And sort of reverse, really, when you think about the fertility and death rates. But anyway, that's the story. And so you see this net increase in births then that's going to what? To push population higher. And so in the long run, we're going to find that we're here, but population will start to rise all the way until it erases all of this temporary gain in the wage. Okay, short run, long run, things that shift curves, things that don't shift curves. More practice is probably the way to get through this. Yes?
How does this fit into the vicious cycle?
I think this is the vicious cycle, right? I don't know. I'm always a little fuzzy on exactly what he means by various things. This is, if you like, this is the iron law of wages, that, you're going to end up back at the same W star. Vicious cycle of what? I don't know. I guess there has to be, you would think vicious would require more deaths or something, right? So I don't know. Yeah, it is rising. Population is rising, and but what's happening? Well, it's not the population rising that's being vicious per se. It's the population rising that then reduces everybody's wage, because you've got a set amount of land, the population is rising, so that means workers start bumping into each other more. And that, I don't know, that's not really the viciousness I think that he usually is obsessed with. I think,
Population rises, then when death rates also rise, does that offset the population increase?
Well, that would happen. But so what's happening with death rates is kind of the summary of what he's asking about. And the answer is, population's on the rise because births exceed deaths. Deaths have actually fallen in how common they are here at the higher level of the wage. Yeah, I'm usually fond of just kind of taking Malthus at his word, literally at his word, and just throwing the words away, because I don't think it's really all that useful. But so I'm somewhat alone in my opinion there. I think there are a lot of ways that people are a bit more sort of poetically inclined to actually see the meaning in what he actually wrote, and not so much, I guess. Okay, so what we see then is, you've got an exogenous technology shock that increases wages, which is good, but the problem is that then leads, it's not really through vice at all. It's actually through, matrimony is the idea in the model here, and it actually is good that you have more money and you can avoid the plague and all that by leaving town or whatever it is, or eat healthier food, and so you don't die as often. But that leads then to this increase in the population size and the same living conditions in the long run. Okay. All right, well, let's start several iClicker questions, if you don't mind. So I'll go ahead and start polling, and if you could pull out your iClickers. There's been some question about whether your iClickers are registered correctly, and I think what I'm going to do is pull out all the data and plop it into somewhere that you can easily see that your iClicker has registered. So remember that today we are just participating because it's good to participate. If you do not have an iClicker today, that's fine. It will not affect your grade. Please have it by next week, and we'll start counting it. Okay, so let me now, having just filled the air with a bunch of nonsense words. All right, so suppose that technology permanently improves the Malthus model. Farmers discover fish as fertilizer, and they all share the knowledge. So which of these is right? I should note here too that income and wage, you should treat those as synonymous. Okay, so why don't we wrap up here? I'm going to close polling in 3, 2, 1. Okay, and so the best answer is B. You'll see a shift in the labor demand curve outward, and that will temporarily raise the wage. Great, good. Okay, so folks are on board with that. And questions about that? Okay. Okay, and so here's kind of a conceptual thing. In the Malthus model, which of these is true? And I think you should imagine, so which is true normally? You could always make up a story where something crazy happens. Okay, so I'm going to close polling in 3, 2, 1, and let's look at the answer. So it should be, again, the answer is B. I guess that's always the answer in multiple choice exams. It's always B. Right? Always B, yeah. So that's kind of the best way of looking at this, that labor is the variable and land is fixed, unless it isn't, right? You could imagine a story in which, in fact, land changes. Questions about that? Yeah.
Sorry, I just have a question about what we talked about previously about the technology changes.
Okay.
You said in the long run, you go to a bigger population but the same living conditions. So would that technically be like worse living conditions because now you have a bigger population?
Well, that's a good question. So she's saying in this scenario where technology produces this outward shift of labor demand, it makes everything better off in the short run, but in the long run, are we really back to the same living conditions or is it worse? And I think what you have in mind there is that, well, land hasn't changed and population has increased, so aren't we more crowded than we were, right? That seems like kind of the logical thing to say. Well, the only thing that matters here isn't really your sort of elbow room, right? It's your wage. And so, you know, the only measure that we've got of how well people are doing is the wage here. So the wage W star is where we end up with, it's what we end up with again, rather. It's where we come back to. So in that sense, we're right back to where we were. Things aren't worse. And, you know, this is a simple model. The best way to think about it is simply. And I think the way you're thinking about it is more realistically. And that's fine, you know. So if you write that on an exam, that's not incorrect. It's just sort of several steps past where the simple model is taking you. Other questions? Okay. So here's another iClicker question, please. Suppose global warming raises sea levels and makes 10% of land permanently unusable for farming. What happens? Okay, a little tougher, a little different. Let's close polling, so please finish up. I'll count 3, 2, 1, and let's close polling. Okay, so the answer is B, again. I don't know why I did that, but I did. So, well, let's see. What's more useful to look at here? I don't know which side. Permanently lowers income. So I guess I better show in the curve here what's going on. So if 10% of land becomes permanently unusable for farming, it's going to be a leftward shift of the labor demand curve. And again, if you like the math, let me just back up here. Oops. Let's see. If you like the math, I wrote it back down here. Where did I write that? There we go. So there's our lambda. I'm sorry, you guys. I'm totally boneheading this up. So lambda's right there. That's land, and if that falls, it's the same story qualitatively as a reduction in productivity. So rather than a rightward shift like we see here, it's going to be a leftward shift in the labor demand curve. And that makes everybody worse off in the short run. You're stuck at n star. That's the level of the population in the short run. And the labor demand curve here is shifted to the left, so it'll intersect n star at this lower wage, and that's very bad. So it reduces. It's a movement along the birth curve down here. It reduces births, and we're going from St. Louis down to San Diego, and here along the death curve, we're going to St. Louis up to Seattle, and so we're raising deaths. So what happens to population in the short run? Nothing. But what happens to population in the long run? It declines. And you've lost a bunch of your farmland. You're less productive. You've got a certain amount of population to start with, but you've got less land to work with, and so everybody's less productive. And what that does is, it just fix the problem. It's this awful way, right, of killing people and not having new people replace them. Bad stuff, for sure. Okay, so B is the best one there. That it shifts the W, the labor demand curve, I guess, the WN curve, and temporarily lowers income or wage. But ultimately, if it's not a story about changing the birth of the death rate, and it isn't, it's about changing the fixed factor that's in the background there, we'll end up back at W star. Questions? Okay, well, here's sort of a more outside the box one. Do you agree or disagree reducing birth rates across the board will permanently raise human well-being in the long run? Based on the Malthus model. Okay, so I'll close polling in 3, 2, 1, and let's see what folks think. Oh, we're all across the board. Great, okay. Yeah, that's good. I think you can kind of argue it a couple of ways. I think answer A is pretty good, but I think C might be what I would go for, just because there's sort of a nuance here. So I think A is pretty good. What does it mean functionally in the model? Well, reducing birth rates across the board is a story about shifting the green curve downward. It's reducing birth rates at every level of wage. And so in the long run, what does that do to the wage W star? Does it stay where it is, or does it move? It moves, and it moves to the right. So that's an increase in the wage. But what has to happen for that to occur? So the birth rate, curve has shifted, but that doesn't actually change the wage, right? What actually changes the wage? The wage is a function of what? Population size. So it can be a permanent rise in, the wage at the cost of what? The population. So that's why I think maybe it depends. It's maybe the kind of the clever, sneaky, unfair answer here. A isn't wrong. I think B probably is fairly wrong, but A definitely isn't wrong. But I think C is probably the one I think might be most right. So we're going to get together and all talk about the exam questions that we write, and we'll make sure we run it past each other and make sure they're not unfair. This might be a bit on the unfair side. I thought it's a good iClicker question, though, because you get full credit just for participating. It doesn't have to be right or wrong. It's sort of a subjective thing anyway, right, this one? It's like, well, what's right or wrong? It's to get you to think a little bit about what this means. That, in this model, it's kind of a dreary prospect. The only way to permanently raise the wage is by removing people, and that's a pretty nasty thing. So if you're thinking about human well-being, it's rather backward, it seems to me, to say, oh yeah, sure, just reduce birth rates. You'll raise human well-being. Well, yeah, and you'll reduce the number of humans. How does that possibly work? It seems like total well-being is sort of a thing you might care about, and that's the number of people times how well off they are. Questions? Tired of iClicker questions? Of course, you want to hear more theory. Okay, here we go. So let's talk about why we're here, what we're doing. Why is any of this useful? Why are we going to study the solo growth model? Well, it's as I tried to make a pitch last time, the solo growth model is really actually quite useful, more so than the Malthusian model, I think, personally, but both are useful. The Malthusian model, I think, has these really nifty applications if you think about non-human populations. For human populations, it doesn't really make a lot of sense much anymore, it seems to me. The solo growth model, on the other hand, however, helps us answer these very important questions. What determines the long-run economic growth rate? And sort of, I guess, in a way by omission, like what does not determine the long-run economic growth rate is kind of the problem. And the answer is going to be it is not determined actually by the saving rate. But that's actually a pretty critical insight. So in the early 20th century, the belief was fairly common among economists and policymakers, et cetera, that the way that you produced lasting economic progress was through capital investment and building stuff, creating big physical goods, big, great new airports. And I think we have come to believe, and data support it, that in fact that's really not true. It's going to give you the impetus of growth in the short run, but the most important part is arguably why we're all in this room together. We're not, if you have maybe noticed, we're not actually building large concrete or metal objects, right? We're not doing that at all. We're using those objects to exercise these, and then you're going to go out into the world and take a job and start coming up with more ideas. And that's probably the true key to growth. Nevertheless, along the way, trying to answer these critical questions: what sustains growth over the long run? What explains why some countries are rich and some countries are poor? Those are really critical things, and the solo model has a lot to say about it. It also, however, by omission, sort of says something about what we don't know. And the answer is we don't know a ton, at least in this model, about technological change. And it's, in particular, of course, in this class, we're thinking about population growth and what impacts that may have on various things. So one thing you might do, well, okay, so we're in economic demography. You might just look at this scatter plot of population growth that's along the x-axis, and GDP per capita is a reasonable index of how well off the average member of a society happens to be. And you might just look at that, and you might then notice that the population growth rate in places like, isn't that funny that Ukraine's right there? I guess Professor Goldstein had these slides last year as well too. It's just kind of fun. Ukraine's everywhere, right? Not if you ask the Secretary of State, though. He'll say, nobody even knows where Ukraine is. Yeah, we do. It's right here. See, there it is. So up at the top is Japan and the United States actually have fairly low population growth rates. So Japan is lower, and I'm sure it still is. It's probably even further to the left, actually. I don't know when these data are from, but I would imagine it's probably from maybe 5 or 10 years ago. The United States is fairly low. Then higher, and here's actually a country that's been in the news recently. So Nigeria is one of the latest victims of the Trump travel ban. And there's some nuance here about what travel we're talking about exactly, what kind of immigration and travel ban, and I think it's actually more about immigration. Anyway, so a lot of commentators have sort of pointed out how ridiculous it is because there are a lot of really smart people in Nigeria. But so here's Nigeria with a very high rate of population growth, it turns out. Yes? How strong is the correlation between these two? Well, that's a really good question, right? That's for stats class. And my guess would be it's probably about 0.4. I don't know. What do you guys think? It's not enormous. Yeah. But there is, I guess I should say minus 0.4, right? Because it's a downward slope. Yeah. We often would call that a football. That's usually the way these things sort of look. The other thing to point out, of course, is that it could be that population growth is causing GDP per capita, or it could actually be the reverse. That's another point. In the solo growth model, though, the perspective is that the population growth rate, in part, then determines what GDP per capita actually is. Another thing, and I tossed this up here too, and I'm not sure how greatly we'll get into this, but it might be in an exam question. What can we say about the age structure of the population, and what does that matter for economic well-being? So populations that are growing rapidly tend to be quite young, and they tend to have saving rates or national investment rates that are pretty low. I think the way to think about that is that if you are a parent, you don't really have a lot of extra resources to save when you have a young child. You're sort of investing every possible thing you have into that young child, especially in this day and age. Once you are a bit older, you have suddenly many more things that you can actually do with your money. And of course, the strange thing actually is that, as people age, it turns out they usually don't spend nearly as much as they could, and they tend to leave a decent amount of inheritance when they finally sort of kick it at the end. So that will lead you in this direction of noticing then that aging populations actually tend to have higher saving rate and so higher capital per worker. And some of that may be perfectly intentional, actually. To some extent, labor and capital are substitutes. And so if you have an aging society with fewer workers, you might then choose, right, to have more capital. So that's one of the empirical regularities that kind of pops out. And so we could model that using the Solo model and think about what that does to things. Down the road a bit, we're going to be talking about technological change. And we'll also talk about natural resources and what we have to say about that sort of thing. And, natural resources matter. They don't show up really here much. I suppose you could think of the Malthusian model as telling you something about a fixed amount of natural resources that never changes, if that's useful. But I think most of us would prefer to have a model in which natural resources actually get used up and aren't there anymore, or destroyed in some other way, something like that. Okay, so with Malthus, we've got land that's fixed and one variable factor. With Solo, we don't really have anything that's necessarily fixed, although it could be. Two variable factors of capital and labor that can both move around. So technology is still just exogenously determined with little stories like we meet a friendly person who has a new production technique that shares it with us, and we get smarter and technology improves and labor demand shifts out and all those sorts of things. Capital, it turns out, also gets more productive as well. And finally, we're kind of taking a step back in our modeling of the population. Here in the Solo model, population is just exogenous. It is what it is, and we think about the implications of different rates of population growth. You could think of it, I guess, as if a country could actually determine what its population growth rate might be, usually through trying to incentivize fertility or things like that. You could think of it that way, I guess. Other points about assumptions are kind of the same, that there's full employment, so there's no unemployment. If labor exists, it works. If capital exists, it's also put into production. And of course, that a little bit less of a problem. But one of the big questions I think is what about this issue of labor, that you might have unemployment, or labor that just sort of removes itself from the labor market because it decides it doesn't want to work. Labor supply curves in real life have some upward slope, and here they don't. They're just vertical. You just inelastically supply labor. And then this point about there's no natural resources, and also we've done away with land. But again, if you want to look back, what we're going to see is something that's really very similar to the math that I wrote on the slide back here. That that just kind of reimagining what these things are and getting the exponents right when you take the derivative especially. N is going to still be labor. We'll just call it L for kicks. And then reimagining that this is actually capital and it's adjustable. It's the same thing. And it's all good. It's a constant returns to scale neoclassical production function that gets us to where we need to be. Okay, so here's the notation slide that we saw last time. It turns out because of constant returns to scale, then it's really convenient to express things in terms of stuff per person or per worker. And here we've switched to using L rather than N, and hopefully that's not too confusing. So there's capital per person, little k. There's output per person, little y. There's a saving rate, so people, they do not consume some part of their income. You want to think about a farmer who produces a crop, and then you could either consume all of the crop, or you could save some of the crop and use it for seeding the next year's crop. That's kind of the concept here, that the amount of the seed that you set aside and don't eat it now becomes capital and useful in the future rather than eating it now. There's a depreciation rate, a population growth rate, well, let's jump ahead one more slide here. So this is the production function. Sometimes we're going to write it without this coefficient of uppercase A because sometimes there are other little a's floating around here and it can get a little confusing. The constant returns part happens because the exponents sum to 1. And let me just say something about that. So why are constant returns important? They, at least in physical inputs, they represent this real cold hard truth of physical reality. If you thought about a manufacturing plant that produces automobiles and it has 100 workers in it, that plant could produce, say, 10 cars a day, just taking numbers out of a hat. Now suppose you duplicated the plant and you hired 100 identical workers to the first 100. So now you've got two plants sitting side by side. Why wouldn't the second plant also produce 10 automobiles, per cycle? That's constant returns to scale. If you exactly duplicate everything, you've doubled or duplicated your output. So that makes a lot of sense. Constant returns to scale in the physical factors of production. So this is the math that you might see, and this sneaks in here again in the textbook. If you've seen this kind of stuff before, this is, it's true. It's the way we've sort of defined it, that, moving, multiplying everything by 1 over L and moving this stuff inside the arguments, okay, blah, blah, blah. I prefer just to say, look, what we're calling this is output per person that is a function of capital per person, which is it's this. It's a power function of this, and it happens to have this concave look to it. I guess the other thing to note here, and this will be confusing because we saw in the c175 model something that kind of looked like this with the total production curve, but it didn't always look like this. There was a funny sort of snaky part here with increasing returns to scale and then decreasing returns, and here we've got just constantly decreasing returns to scale. This, however, if you're an econ major, is probably much more familiar because you'll have seen this in your other classes. The c175 model, not so much. The c175 model is sort of more useful for historical demography, not so much useful for intermediate macro or micro, really, because it's sort of a different time and place, I guess. Okay. So saving per person, then, per capita savings, is this distance here. It's the functional value of the saving rate times income per person, little y. The difference then between total income per person, which is this level on the top graph. So whatever capital per we got at this distance here from the origin, tracing it upward through a vertical line, here's the amount of saving per person or per capita saving, and then whatever is left over, the difference between this line and that is the per capita consumption. And you might ask yourself, is this an economy I would like to live in? Roughly how much would you say, just using your eyeball, roughly how much out of your paycheck are you forced to save? Is that like a tenth? Or like a third? It's more like a half, right? That seems like a pretty high saving rate. Saving isn't fun, right? Saving is not fun. Saving is a means to an end. And so underneath it all too, let's keep in mind that that what this is about is trying to think about maximizing human well-being, and doing it in a sustainable way is the other part of all this, right? We don't want to destroy the earth and all that. But you could think about that as being subsumed in some sense in a calculation where you imagine, well, we're maximizing the consumption of everybody here in the room, but we're also maximizing the consumption of all future students and all future humans who are able to live sustainably then in the earth. And so bottom line, we don't really care about maximizing income per se. You care about maximizing consumption. That's how fun life is. And this doesn't look very fun to me. This looks rather onerous. This is you have to save to produce more capital, half of your income, just because we've drawn it that way. So let's keep that in mind too, that saving is important because you can produce physical capital, airplanes, airports, train stations, railways. You can produce all that stuff out of saving, out of not consuming your income. But the point is that you want to consume your income. You want to spend on movies and food and trips and all that stuff too. So this isn't costless. There's a real problem here that you can't have your cake and eat it too. You've got to do a little bit of both. And having a higher saving rate means that the consumption rate is lower, and that's a problem. Okay, so capital per person over time requires new investment that comes through saving. So the resources then that you accumulate by working and producing stuff, some part of that needs to be plowed back into the capital stock, and we looked at this last time. So let me kind of jump ahead and kind of get to the punchline here. There's an additional curve that has to do with the rate at which capital breaks, the depreciation rate, that's little d, and also the rate at which capital is spread across more workers. Trying to think of the reverse of the concept of capital deepening here, shallowing, I guess. So n is there also. N plus d then is the slope of that red ray from the origin. With a higher rate of population growth n, that ray has a steeper slope. It pivots counterclockwise. Likewise, also with a higher rate of capital depreciation, if the stuff just breaks more often, you'll see a pivoting up that way. And the equilibrium, the steady state here is, as it usually is, it's at the crossing of these two things, the saving curve and the depreciation curve right there. Excuse me, and we're going to be pushed there over time. So you could think of this as the death rate of capital against the birth rate of capital. So if you're in a position over to the right here where the birth rate is lower than the death rate is higher than the birth rate, equivalently. It must mean that more capital is being retired than is being brought online. And so if we're over in this part, we're going to be shifted back toward K star. The same is true over here. So the green line is above the red line, so that means that there's more net saving per worker than depreciation per worker, and we'll be headed back toward the steady state K star. Okay. All right. So implications. In the steady state, once you've reached it then, there's no change in output per worker. What happens to the size of the economy? Surprise, there's growth. Provided that there's population growth, there actually is growth in the economy here, which I think is maybe not that obvious. Because if you just look at this picture, let's just back up a slide, right? It kind of looks like you're stuck and that's the end of the story and there's no growth. Well, there's no growth in certain things. There's no growth in capital per worker. There's no growth in output per worker, which you could think of as average income. That's true. And it also is true that there's no growth in the marginal product of capital and there's no growth in the marginal product of labor. That's also true. But underneath it all, if in fact we're saying K star is fixed, that's the capital labor ratio, and if labor is growing at rate n, then so is capital and so is output also growing at rate n. And that's the constant returns argument here, that if this is the production function, then what you get is 1/3 the growth rate of capital plus 2/3 the growth rate of labor. If they're the same number, you get back 100% then of this growth rate. And that's the story. So output per worker is also fixed. The economy itself, total output, is actually growing over time. And so that's very different from the Malthusian model. Okay, what happens if the saving rate rises? That's a good question. What happens if the population growth rate rises? So we've got 15 minutes left, and I want to touch on these things and make sure we do some more iClicker questions on the Solow model. Let me do this slide and then just stop and ask for questions at that point. Okay, so suppose you've got faster population growth. And why might that happen? Well, absent some other things. It could be that, a breakthrough against mortality means that people die at a slower rate, and so you actually have more population that way. It could have happened if, say, people decide to have larger families and we're having more children, right, and fertility rises and the population growth rate rises. It could also happen if there were technological changes that helped reduce infant mortality, which in developing countries has always been the story, that infant mortality was very, very high, and the net, population growth rate then was, fairly low. Even with high fertility, babies are being born and then dying tragically. So a number of things could happen here, and this might be the story then in a country entering the demographic transition where suddenly mortality rates fall for very little kids, and that's a very good thing. It also raises the population growth rate. And so what you would see is a counterclockwise pivoting then of this total depreciation line. So n prime, which is the new population growth rate, is bigger. So the dashed red line is steeper than the first one, and that means that the new steady state will be down here at k star prime. Let's step through this carefully now, of course, thinking about long run and short run. Okay, so the population growth rate rises. That can happen quickly. It's a growth rate. In the short run, what doesn't change quickly? So the level of population is actually the same in the short run, but it's still growing, and it's growing more rapidly. Most importantly, the level of the capital stock stays the same in the short run. So we're still at K star, which is capital per worker, because both of those things, the number of workers and the amount of capital, are the same. But what is now true about total depreciation and total saving here at this K star? Well, the total depreciation, or if you will, the death of capital, is higher. It sounds like an awful Marxist book title, right? Read The Death of Capital by Karl Marx. The death of capital is higher. And so what that will do is pull us in this direction here toward K star prime, where again these things are just equalized. So to the right of K star prime, provided that we're now in this new world of higher population growth rate, we'll always see depreciation in excess of new capital being saved and invested and produced, rather. So we're going to be moving toward K star prime in the long run. Okay. So what could be done if you were the omniscient central planner of a country, or I don't know, a democracy got together and said, "Oh no, this is happening. What should we do?" "Oh, we don't care." Well, okay, that's possible, but what's true about the level of output per worker now, given that this has happened here on the left-hand side? It's lower. Output per worker is lower there because there's a faster rate of population growth. Given the rate of saving that the country has, it's not producing enough new capital to outweigh this effect of the additional workers who are born and start using the capital. So there's a lower capital labor ratio than before, and that's not good for output per worker. You've got workers who now have less capital to work with on average. What could you do? Well, if you had the saving rate as a policy tool, you could increase the saving rate then from what it was to S. So here's little green s and here's little green s prime. So that's representing then an increase in the saving rate that would push this curve up. And if you magically could just choose this point, right, you'd say, "Oh, this must return us back to normal if you just increase the saving rate by whatever amount this is, and bring us back magically to K star." That's one thing that could then offset this nasty effect, and that would increase output per worker then over the long run back to where we were. Notice, however, in the short run, so let's talk about the sort of intermediate step here, right? There's kind of two long runs, unfortunately. here's a story about the population growth rate changing that's a short run and a long run there. And now we're talking about a policy change that takes us from the long run that was here and now creates a new short run and another long run. So it's a little confusing. In the short run that we're over here, so the population growth rate has already risen and that's pushed us down to K star prime, and it's reduced output per worker to Y star prime. Okay, the prescription is, all right, well, this is not good. What shall we do? We shall raise our saving rate. Okay. Well, what's happened to output per worker? It's fallen. And so now you're saying, all right, people, now you must save more and consume less. Well, that sounds like kind of a kick in the teeth, doesn't it? I mean, that's the policy prescription. In the short run, save more. All you gotta do is save more. But the problem is it's coming out of a smaller amount of income per person, which is kind of a pain. Now, there's a more complicated story that one might run into in graduate school with this sort of thing. It depends which side of kind of the optimal amount of saving that you might be on. But the problem is that, you run this cost. In order to save more, you have to consume less, and that's not always the easiest thing to do. Okay, so we've got about 10 minutes left, and what I'd like to do is jump to the end and do some iClicker questions in the time that we have remaining. Okay, so what happens in the long run if global warming results in a faster rate of capital depreciation? So suppose we're all tropical and the rain just kind of melts everything. What happens in the long run? Okay, so let's stop polling. I'll count down 3, 2, 1. Okay, so I think the best answer here is, again, of course, B. Good, great. Okay. Yeah, there it is, answer B. So a rise in the depreciation rate is the same as a rise in the population growth rate. It makes the red curve more steep. It pivots the thing counterclockwise, and that's going to produce a lower level of capital per worker and a lower level of output per worker in the long run. In the short run, it doesn't do anything to either of those, but it raises the specter of imminent decline. Questions? Okay. All right. This is harder. What happens in the short run if a war destroys half of the capital stock? Questions? Okay, a little harder. So I'm going to count down and close polling in 3, 2, 1. Okay. So in the short run, if a war destroys half of the capital stock, so where is the capital stock in, I guess let's run with the graph. I mean, we could do the equations if you're more comfortable with that if you like. So here's capital per worker. Suppose a war destroys half of the capital per worker. How do you illustrate that? You're here in the steady state originally at K star, and if half of the capital gets destroyed, you're going to be jumping from there down to a point here, K star over 2. Right? So half of the capital stock gets destroyed, and so we'd find ourselves down here. And at that point, here's the depreciation per worker, the red line, the saving per worker is the green line, and up here we'd find output per worker right there. So in the short run, capital per worker and output per worker both fall. So answer B is the best one. And Good job. Yeah, so both fall in the short run. Okay, how about this one? What happens in the long run if a war destroys half of the capital stock? And so here, I guess, the vague part of this is what happens, and then the question should be relative to what, and the answer is relative to before the war. Okay, so I'm going to close polling in 3, 2, 1. Let's close polling. Okay, so the answer is nothing. Nothing will happen in the long run relative to before the war. So that's good. So a majority of folks got it. And so let me just briefly talk through why the answer is C. Nothing will happen relative to before the war. So in the short run, half the capital stock is destroyed, so we're going to jump from K star down to halfway down here, K star over 2. And at that point, saving per worker is above depreciation per worker, and that will push us back in this direction. And we have to keep being pushed in the direction back toward K star. This is the canonical treatment of why there was rapid growth in post-war Europe. Because the capital stock had been greatly destroyed, and with no changes in any of the underlying sort of fundamentals, if you will, that will produce rapid growth back to the steady state. Questions about that? I've got one more, and in the time remaining, we'll just get to that. Okay, is it always better to have a higher saving rate? Okay. Eye clicker fatigue, and we're at almost at the end of our hour, so let me go ahead and close polling. 3, 2, 1. Okay. So I think I like the answer B, yeah. As, of course, the answer has been the whole way. The answer is always B. I think that's the best one here. C is probably not the right answer. The saving rate definitely does matter. And A is true, but I don't think it's quite the best answer. All right, have a great weekend. Thank you. See you Tuesday.